Hi, it's Professor Jones here to give you a brief overview of Section 1.4, which deals with complex numbers. The objectives of this section are to add and subtract complex numbers, multiply complex numbers, divide complex numbers, and perform operations with square roots of negative numbers. Accompanying videos for each of these four objectives will be provided separate from this video. Let's look at the complex numbers and imaginary numbers. The building block of the set of complex numbers is the imaginary unit I, which is defined as I equals the square root of -1, where I squared equals -1. I just want to call your attention to the fact that at the bottom of the page on the left, you have the definition of I, which is equal to the principal square root of -1. On the bottom of the page on the right, you have the definition of I squared, which is equal to -1. The set of all numbers in the form a plus bi, where a and b are real numbers and I is the imaginary unit, is called the set of complex numbers. The standard form of a complex number is a plus bi, where a is called the real part of the complex number and b is called the imaginary part of the complex number. If b is 0, the complex number is a real number. If b is not 0, the complex number is called an imaginary number. We can perform operations on complex numbers. Recall the form of a complex number is a plus bi. To add, subtract, and multiply complex numbers, we treat the complex unit I as if it were a variable. But remember, it is actually a constant value, where I equals the square root of -1 always. Our next topic is the conjugate of a complex number. For the complex number a plus bi, we define its complex conjugate to be a minus bi. The product of a complex number and its conjugate is a real number. So a plus bi times a minus bi is always a real number. There's an accompanying video to give more information about that. Complex number division is another operation that we can perform between complex numbers, and the goal of complex number division is to obtain a real number in the denominator. We multiply the numerator and denominator of a complex number quotient by the conjugate of the denominator to obtain this real number in the denominator. This is the main use that we'll have for the complex conjugate. Last but not least is the principal square root of a negative number. For any positive real number b, the principal square root of the negative number -b is defined by the square root of -b equals I times the square root of b. So those are the main ideals of section 1.4. And I hope if you need more insight into any of these ideas that you'll view the associated videos.